Yes. Good gentlemen, my name is Sinta, and today, on this special occasion, allow me to present my research entitled Chemical Constituents from the branch of Garcinia schomburgkiana and their cytotoxic and alpha-glucosidase inhibitory activities. So first of all, let me introduce you the plant that is used in this research, which is Garcinia schomburgkiana. This plant commonly found in the Southeast Asian region, including Thailand, Laos, Cambodia, and Vietnam. In Thailand itself, the distribution of this species in the northern and area. Moreover, traditionally, Garcinia schomburgkiana had been used as an expectorant, laxative to treat cough, also as a diabetes and menstrual treatment. Previously, it has been reported that Garcinia schomburgkiana contains various phytochemicals, and those are biphenyl, flavonoid, depsidone, xanthone, and bisphosphonone. Next, I would like to show in brief about the previous study on various parts of Garcinia schomburgkiana. Let's start from the bark part. So in 2012, Paul worked on the petroleum ether extract of the bark of Garcinia schomburgkiana. Here they isolate two new compounds, and they also evaluate the cytotoxicity against HeLa cancer cell lines. And as a result, Coanin and fuscasanton B show a good cytotoxicity toward the HeLa cell lines. Still from the box part, Kenakam studied on the dichloromethane extract, and here they found two new compounds. They also test for their cytotoxicity against 5 human cancer cell lines, and it turns out that all of the isolated compounds give strong cytotoxicity toward all 5 human cancer cell lines. Garcinia schomburgkiana in 2013, Mami studied about this extract, and then they found out that they isolate a new compound, which is schomburgbiphényl, and they also evaluate the cytotoxicity against SW620 cell line. And as shown here, that oblonicolin C and butyferon K exhibit a very strong cytotoxicity. Now, move to the roots part of Garcinia schomburgkiana. Sukandar and his co-workers studied about the dichloromethane extract of this part, and they isolate 3 new compounds. So, against KB cells, and compound schomburgxanthone A show a good cytotoxicity. Meanwhile, in 2016, we studied on the methanol extract from the fruits of Garcinia schomburgkiana, and they also evaluate for their cytotoxicity against HeLa cell lines. And from this research, they also report 8 new compounds. Move to the twigs part. Lindo studied on the ethyl acetate extract of this part, and here they isolate and they also evaluate the alpha-glucosidase inhibition using rat small intestine method. And as shown here, that schomburgkisanton and grifipavisantones give a good inhibition. And lastly, from the branch part, in 2016, Imron and his co-workers studied on the acetone extract, and they also studied on the anti-radical activities. Next, this slide shows about the 2 most common global health problems on the World Health Organization data. As we can see here, that around 18 million cases of people are suffering with cancer in 2018. Meanwhile, around 422 million cases of people are suffering with diabetes in 2014. And this number is predicted to keep increasing year by year. As for the initial method to screen the cytotoxicity is by using the MTT assay. Meanwhile, for the diabetes is using the alpha-glucosidase inhibitory activities. To sum up all of the previous work, we note that Garcinia schomburgkiana contains various phytochemicals with several pharmacological properties, and there have been no reports on the phytochemicals from the dichromethane extract of the branch of Garcinia schomburgkiana. And cancer and diabetes are the prevalent global health problems. Hence, this is to isolate and purify the phytochemicals from the branch of Garcinia schomburgkiana to assess the cytotoxicity amongst all isolated secondary metabolites against 5 human cancer cell lines, and to test the alpha-glucosidase inhibitory activity of the isolated compounds. Now let's move to the experimental section. Begins with the preparation of the plant material. So the branch of Garcinia schomburgkiana were collected from Talinchan district, Bangkok, Thailand, and it was identified by Dr. Sutira from Balai Rukavech Botanical Research Institute. We move to the extraction part. All of the branches that were collected was then ground into powder and macerated with dichloromethane for 6 days. After that, the solvent was evaporated by using rotary evaporator to yield 90 grams of the dichloromethane fruit extract. After that, the dichloromethane fruit extract was then fractionated by using various column chromatography technique and also by radial chromatography to finally yield 13 compounds. These 13 compounds was then elucidated by spectroscopy. A spectral result was then compared with the literature to determine the chemical structure of the compounds. After the isolation step, we move to the bioactivities assay. Here, all of the isolated compounds was then evaluated for their cytotoxicity towards 5 human cancer cell lines, including KB, HT29, HepG2, HeLa-S3, and MCF7 by using MTT assay. And this MTT assay was done by Dr. Jantana from the National Cancer. Now, move to the next part. The isolated compounds was also evaluated for the alpha-glucosidase inhibitory activity using sucrose and maltose as the substrate by rat small intestinal method. As a result from this research, we have successfully isolated 13 compounds, including 2 chalcones, 7 xanthones, 2 polyphenylated benzoyl fluoroglucinol, 1 benzophenone, and 1 biphenyl. As we've seen here, the first 3 structures that I marked with green square are firstly found in genus Garcinia. And in addition, for the chalcone group here, to the best of our knowledge, it's very rare to be found in the genus Garcinia or Garcinia schomburgkiana. So I would like to show in brief about the proton NMR of one group, start from compound 10. So from previous research, this compound was found from Peperomia obtusifolia. And this research was the only report that showed that this compound was found in nature. As we can see here from the NMR spectra, there's a peak 12.3 ppm here. These peaks belong to the chelate group, hydroxy group here, shown with the green color. And after that, there are peaks at around 3.5 ppm. These peaks belong to the methylene group alpha and beta, shown with the orange color. And finally, peaks at around 7 ppm. These peaks belong to the aromatic proton. Now move to the next compound from the chalcone group. This compound 11 here, previously found in the Lindersia brassy. As we can see from the proton NMR spectra here, there's peak at chemical shift 9.3 ppm with the green color. This peak belongs to the then it also have peak at chemical shift 3 ppm. These peaks belong to the methylene group alpha and beta. And lastly, at chemical shift in the range around 7 ppm, it's the chemical shift belongs to the aromatic proton. In this slide, shows the result from the in vitro cytotoxicity against 5 human cancer cell lines. As we can see here, almost all of the compound shows weak to inactive cytotoxicity, except for compound 2 and compound 1. Compound 2 shows strong, whereas compound 1 shows moderate cytotoxicity. If we compare the compound 1 and compound 2 with structure activity relationship, we can see here that in compound 2 or obligatorin C, there are 2 extra hydroxy group and then have 2 extra groups. And this might increase the cytotoxicity of the compounds. The next part is the result from the alpha-glucosidase inhibitory activity using rat small intestine method. As we can see here, that only alkuparin show an activity toward the alpha-glucosidase. But if we compare with the acarbose as the positive control, the IC50 value is 5. I have mentioned before that we use maltose and sucrose as the substrate for the alpha-glucosidase inhibition. And here is the result from the maltose substrate. So we use 5 different concentration, and then the IC50 value was calculated by using the linear integration. And here is the result from the sucrose substrate. For conclusion, 30 compounds were successfully isolated from the branch of Garcinia schomburgkiana. Compound 9, 10, and 11 were found for the first time in genus Garcinia, and this might be served as an important chemotaxonomic marker to differentiate Garcinia schomburgkiana with other Garcinia species. Obligatorin C or compound 2 exhibits the most potent cytotoxicity against 5 human cancer cell lines in the range of 5.15 to 7.9 micromolar. Alkuparin or compound 13 alpha-glucosidase inhibitory activity with IC50 values of 49.23 micromolar in sucrose and 98.20 micromolar in maltose. As the future work from this research might involve further investigation of the active compounds for an in vivo assay. Also, modification and synthesis of natural product-derived compound as a novel potent drug that might contribute in the drug discovery. Last but not least, I would like to say thank you to the Graduate School of Chulalongkorn University for the Master Scholarship Program for Asian countries, and also to my advisor, Associate Professor Dr. Santi Tipiang, also to my research group from the Center of Excellence in Chemistry, and then for Dr. Jantan Najah from Natural Cancer Institute, and lastly, Dr. Sutira from the Waleruka Botanical Research Institute. Thank you for your kind attention.
Yeah, thank you very much for your interesting talk. So if any audiences have a question, so it's now the time. You can ask Miss Nindyashinta about her work. We still have some minutes left. Okay, and then maybe I can start. I wonder about the amount of the compound, especially those exhibit anti-cancer activity. Do you have any idea about the amount?
The milligram.
Milligram.
Or is it correct? Yes, Ajahn, I put it in the manuscript, but I didn't put it in the presentation. And
I see. So no, I just want to know that because you plan to further modify its structure, right? Then meaning that the amount should be relatively high, right?
yes, Ajahn, for the synthesis.
I see. The next question is related to the molecular mechanism of those compounds. How do you have any idea how it inhibit or it can kill cancer cell?
Oh, so actually, I didn't study about the mechanism to the cancer cell, Ajahn. We only like predicted from the structure activity relationship here. Like if we compare from this one is the 7 epiglucianone compounds, this one is the obligatory. We can see the cytotoxic. The IC50 is decreased because of the perennial group here that might enhance the cytotoxicity, because from the previous work, it shows that the presence of perennial group here makes the compounds more hydrophobic, and then it enhances the cytotoxicity. So we just like guessing from the activity relationship.
All right. Any other question? Any questions from the audience? All right, then if we got no question, then I'd like to just thank you, Miss Nindyashinta, again for sharing her work with us. Thank you very much.